with a little review from geometry with our special triangles that you guys learned in the past. Those special triangles, well, I shouldn't say special triangles, special ratios in your triangle are sine, cosine, and tangent, which we use SOHCAHTOA to remember those. You guys remember doing sine, cosine, and tangent? Yes. Okay, great. All right, so what are sine, cosine, and tangent? They are ratios of two sides of a right triangle. So the picture you have in your notes here, we've got a right triangle. This is right triangle with angle C is our right angle. Notice how everything's labeled in this triangle. We're going to see a lot of triangles this semester, and they're not always going to be drawn for you. Sometimes they'll just say this angle is this, and this angle is this, and you're going to have to know where to place things. If they are the same letter, they are opposite each other in the triangle. So you can see side C and angle C don't touch. Side A and angle A don't touch. Same with B. Okay. Also, capital letters are angles. Lowercase letters are sides. Once you have a right triangle, one of the two, what we call acute angles, the two that aren't the right angles, one of them is our angle of reference, which a lot of times we use theta to represent that, but there's going to be other Greek letters that are going to be there as well. Once one of your angles is labeled with theta or whatever the reference angle is, you can label your sides with opposite, adjacent, and hypotenuse. The hypotenuse, of course, is the side that's always opposite your right angle, so that would be C. And then these other two legs of our right triangle are either opposite or adjacent. Adjacent means it's touching your angle of reference, and opposite means it's not touching your angle of reference. So depending on where that angle is, the opposite and adjacent might flip. Okay, so in this picture, side B would be adjacent and side A would be opposite my angle of reference. And of course, C is the hypotenuse. It's always the longest side. Then we look at sine, cosine, and tangent. So what you have here is kind of like the wordy version of it, the opposite side over the hypotenuse, and then the labeled side, A over C. Where the so part comes from, sine, opposite over hypotenuse. So that's how we remember it. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. The value of sine, cosine, and tangent is not what the angle is equal to. It is the sine of the angle, which we don't know what that is right now. It could be, 42 degrees or 72 degrees or 63 degrees, whatever that is, equals some number. This number is going to vary depending on what the two lengths of the side of the triangle are. Okay, so what is a trig function? It is a ratio, two sides divided in a right triangle. That's the definition of sine, cosine, and tangent. Then, once we have sine, cosine, and tangent, we can take their reciprocals and we get our other three main functions. The reciprocal of sine is cosecant. So instead of opposite over hypotenuse, we have hypotenuse over opposite. And then same with the other ones. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. So what you want to remember from this, you want to know SOHCAHTOA, that gives us the first three. And then you also want to know what are reciprocal pairs. If I flip sine, I get cosecant. If I flip cosine, I get secant. And if I flip tangent, I get cotangent. Because then you get the other three pretty quickly. Okay, so that's what we're going to start by doing, is finding the values of these trig functions from our right triangle. So the next slide has a right triangle here for us. It says find the exact value for all 6 trigonometric functions for our angle theta. Now, one thing that's missing, if you want to find all of the trig functions, is the side. We have to find all 3 sides, and only 2 of them are labeled. So if you have a right triangle, what formula do you use to find the missing side of a right triangle? You use? Right, which is called what? Yes. Okay, so C is always your hypotenuse. A and B are just the 2 legs. Doesn't matter which one's which. So here, my C is 9. That's my hypotenuse. And then A or B, whatever one you want to fill it in for, is 5. I'll call that A. And I'm going to solve for B. So let's see. 5 squared, that's 25. 9 squared, that's 81. If I subtract 25, I get B squared is 56. Take the square root to solve for B. Rad 56. Normally in an equation, we're going to put a plus or minus in front of this, but we're talking about the side of a triangle. So for right now, it's not going to be negative. Everything's going to be positive. If you have a radical, you want to make sure you can reduce it. What does rad 56 break down to? This one does reduce. Yep. Yes, so 4 times 14 gives me 56. The square root of 4 is 2. And square root 14 we cannot simplify. So that's going to be that missing leg. Okay. All right. So now to our 6 trig functions. Sine, theta, cosine, theta, tangent, theta. You want to get in the habit of every time you write a trig function, there is always an angle next to it. Sometimes we know the angle, sometimes we don't. Like right now, we don't know. I'm just going to put the theta there. On the other side, then, we're going to do our ratios. One side divided by the other, and that's the answer we're looking for here. Okay, so for sine, I need opposite and hypotenuse. Opposite over hypotenuse. And you can, if you want to, in your triangle, label these. I know my hypotenuse is 9. Which side is opposite? The 2 or the 5? Which one's opposite my theta? The 2 is opposite, and that makes the 5 adjacent next to my theta. So if I want to divide opposite over hypotenuse, it's 2 rad 14 over 9. And then that's the exact answer. We're just going to leave it like that. You could look at 2 over 9 and make sure that doesn't reduce. It doesn't here, so this is our final answer. Cosine is adjacent over hypotenuse, which is just 5 over 9. Doesn't reduce, final answer. Tangent, opposite over adjacent, 2 rad 14 over 5. And the 2 over 5 doesn't reduce, final answer. Okay, so those are our 3 main trig functions. To get the other 3, we're just going to take reciprocals of these. So you need to know which functions go together. Sine and cosecant go together. They're reciprocals of each other. Cosine and secant, tangent and cotangent. And again, every time you write in a trig function, we're putting an angle next to it. All you have to do now is flip your fraction. So 9 over 2 rad 14, 9 over 5, and 5 over 2 rad 14. The only issue then becomes, for at least the top one and the bottom one, we have a radical in the denominator. We don't want a radical in the denominator. We want to rationalize. So for those 2, I'm going to multiply by that radical over itself. You don't have to multiply by the whole denominator. Just by the square root you don't want anymore. So I'm going to multiply by square root 14 over square root 14. So multiplying by something over itself is just like multiplying by 1. So it's just going to change how it looks, not what it's equal to. And we're just multiplying straight across. So cosecant will end up being 9 rad 14 on top. On the bottom, what do you get when you multiply a square root times itself? Like if I multiply square root 14 times square root 14, what is that? You get? It's just 14. Yeah, if you multiply, like, think about square root 9 times square root 9. Square root 9 is 3. Square root 9 is 3. 3 times 3 gives me 9. A square root times itself just gives you that number that's underneath. So those square root 14s give me a 14 times 2. I get a 28 on the bottom. Same thing happens with the other one. I'm going to get 5 rad 14 on top, and then 2 times 14, 28 on the bottom. Okay, and then you could turn those into decimals if MathXL wants them. Usually we're going to leave these as exact answers, though. Okay, so your final answer is just that ratio of the sides, the 2 sides divided of whatever trig function you're looking for, whatever that ratio it's asking for is. Okay? Any questions on this one? All right, so the next problem is for you guys to try, but I'm going to get you started on it. So this time, no sides are labeled, but it gives us a little information. It says cosine of theta is 1/3. And this picture, guys, I don't even really need to give you this picture. This is just an arbitrary right triangle. Any right triangle picture would do for this. Okay, so usually they're not going to give it to you. If they say cosine of theta is 1/3, they're telling you the ratio of two sides. They're giving you information about two of the sides. We know cosine is adjacent over hypotenuse. So in this picture, you can label the adjacent side as 1 and the hypotenuse as 3. And then you could do the Pythagorean theorem to get that opposite side that you're missing. Now, could the sides be like 3 and 9, and then I'd still have a ratio of 1/3? Yes, but if I made them 3 and 9 or 4 and 12 in my triangle, they would end up reducing in my trig functions anyway. So we're going to use these numbers because they are the most reduced, and we won't have to reduce all of our answers later then if we use them. Okay? So go ahead and see if you can finish it up then. Find that missing side, write down all 6 trig functions, and then maybe we'll put them on the board to check them here in a little bit. All right, do we have any questions on anything here? And about the rationalizing or anything that we want to go through a little bit more? How'd you do? Good? Overall? Do you guys remember doing stuff like this in geometry? Ringing a bell? Okay, good. Okay. Can I erase it? All right. All right. Special triangles from geometry now, as promised. Okay, so 45, it's a little harder to see on there. Hopefully it's a little better on your paper. 45, 45, 90 is the first special triangle you guys learned about in geometry. And it's special because it's isosceles, so the two legs are the same here, whatever that length is, they're labeling with an A. You probably used an X when you did it in geometry. It doesn't matter what the letter is. And then the hypotenuse is always that length, whatever it is, times the square root of 2. So knowing this alone in the 45, 45, 90 triangle is enough to get numerical trig ratios for this triangle. So that's what we're going to do. We're going to find all 6 trig ratios for, and now we have an angle of reference, 45 degrees. You can, in this picture, label either of these angles with theta. So on your screen there, if you want to put a theta next to one of them, it's fine. It doesn't matter which one because they're both 45 degrees, and the opposite and the adjacent legs are going to be the same thing either way. All right, so here we know the angle. So when I write my trig ratio, it's going to look like, instead of sine theta, it's going to be sine of 45 degrees. I know the angle. The angle always goes next to my trig function. And then next to that, we're going to do the ratio. So the ratio for sine is opposite over hypotenuse. Well, an opposite side is going to be A in this picture. And the hypotenuse in this picture is A rad 2. So what ends up happening here is I have an A on the top and I have an A on the bottom. It's a common factor. They're going to cancel. And that's going to leave me with 1 over rad 2. And then I want to rationalize that. So I'm going to multiply by square root 2 over itself. And I'm going to end up with, in the numerator, square root 2, and in the denominator, 2. And then that's the final answer. So it doesn't matter what length these sides are, the sine of 45 degrees, no matter how big the triangle is always going to be rad 2 over 2. Cosine of 45 degrees is adjacent over hypotenuse, which is also A over A rad 2. So it's going to simplify the same way. I'm just going to skip that middle step there. It's the same ratio. I know it's going to be rad 2 over 2. Tangent of 45 degrees is opposite over adjacent. So A over A, which is going to simplify to 1. So tangent of 45 degrees is 1. Now I'm going to flip them all. So the reciprocal of sine is cosecant. Now this is where in trig we're going to find opportunities to work smarter, not harder. So I could flip this guy if I wanted to. I could flip this guy if I wanted to. I'm not going to use the first one because it still has a's in it, so it seems like I'm adding more work for myself. I'm not going to flip the last one because then I'm going to put a rad 2 in the bottom, and I'm going to have to rationalize and then probably reduce again. I'm like adding 2 steps. But look here, 1 over rad 2 is one of the equivalent ratios that we had. If I flip 1 over rad 2, I just get rad 2, and I don't have any work for myself. So you can kind of look at your 3 options in these. Like I can flip this guy, or this guy. But that middle one, if I flip it, I don't have any simplifying to do. So I'm going to use that. Okay. But if you use the other ones, you'll eventually get to the same spot. The same thing's going to happen with secant. It's going to end up being rad 2. And then for cotangent, the reciprocal of 1 is just 1. So those ones end up being pretty quick. Those of you that did the unit circle before in like algebra 2, do you recognize the rad 2 over 2 as being something that was on the unit circle at some point? Okay, that's where these numbers are going to start appearing in a little bit, where we're going to get values for our unit circle is coming from these special triangles. Okay, so now the next 2 slides on your slideshow there are, and I think I separated it, didn't I, on yours into 2 separate slides? Okay. So you are going to, with your groups, and this is our goal for the end of the period, find all 6 trig functions for our 30, 60, 90 triangles. Now, 30, 60, 90 triangles are similar. They've got their special ratios, but they're not isosceles. So the answers you get for 30 are going to be different than the answers you get for 60. For 30 degrees, you need to label 30 as your theta, angle of reference. For 60 degrees, you need to label 60 as your theta, angle of reference. When you're drawing a 30, 60, 90 triangle, the A or X or the single length, the smaller side is always opposite 30. Always opposite 60 is that length times the square root of 3. And your hypotenuse is always 2 times that smallest length, whatever it is. Okay, so that's your goal for the next, I don't know, 10 minutes or so. Find all 6 trig ratios for 30, and then do it again, all 6 trig ratios for 60. And then we're going to put those on the board and check them. Okay. Reduce, rationalize, all the things. We're not going to like have to recreate the wheel on these over and over again. These are going to be numbers that are on your unit circle. And if you know how to use your unit circle, you can look at the circle and know what the cosine of 30 is without having to draw these triangles and find the ratios. But we need to do it at least one time to be able to build those values on the circle. That's what we're going to do in section 5.3. Okay, so that's the first half of 5.2. Tomorrow, we're going to do the second half, which is a couple word problems and a couple trig properties that we're going to start using, and that'll wrap up the section. So you guys can do any of these ratio problems, the right triangle problems. You can get all of those done tonight if you want to start on your Math Excel. We are not yet solving for angles, okay? So everything you're solving for right now is just a side length or a ratio of side lengths, and then we'll get to angles later on in the chapter. Okay? Questions for me right now? All right, so we'll wrap it up there. I'll do cell phone money. You got about 15 minutes. If you want to start working on Math Excel, you can. And there's a new circuit training over right triangles if you want to try it. Woo. There's mine. Hold on. Let me blank it out. There we go. Okay.